Hello, good morning, everybody. Good afternoon, everybody, and thank you for attending these sessions about Veloce proFPGA and how it is helping to accelerate the verification of the software. I'm Gabriele Pulini, and I'm part of the Siemens EDA organization in product marketing. So today I will cover a few aspects of the proFPGA solution, showing what's the strategy and how it fits into the Siemens EDA strategy for offering accelerated solution for hardware and software verification. And as well, we will get into details of the proFPGA hardware prototyping architecture and different solutions that are offered with it. And as well, we will cover how the software helps designers to accelerate the bring up of designs on this platform. And I will conclude with some case studies to show how effectively the proFPGA platform is used by different customers around the world. And if you look at the software side of the verification and design process, we see that the software is complexity is exploding. I mean, more and more applications are built into the system, and so the workloads related to these applications and the software goes with them, I mean, is dictating and is driving as well the choices of the hardware architecture that will be implemented. And as well the software impacts the product schedules, obviously, because it's complexity, and as well is impacting the cost, dramatically the cost of the overall design and verification process of today's designs. As we can see here on the graph, I mean, the software is getting the portion of the cost of verifying and developing the software is getting to the majority of the overall cost of the project. So this is why, I mean, there is a particular focus from Siemens EDA offering a set of optimized tools for accelerating the hardware and software integration verification, as well validating the software on the real operating conditions. And for that, we needed to offer a complete set of optimized engines for accelerating the different phases of the project cycle. So this offering from Siemens EDA includes three different types of hardware engines. An hardware emulation, the Veloce Strato hardware emulation, I mean, with its characteristics of fast interactions allowed to the user, is a tool that is used at the early phases of the design process, when architectures and RTL is still under constructions and under definition. And so the verification process requires a lot of interactions with the tools, because we are running a short test probably, and we do continuous debugging and corrections of potential problems that have been identified. And so the characteristic of this engine, together with the performance, is the interactivity that offers to the user. In fact, is based on the custom chip, a reconfigurable custom chip, instead of using commercial FPGAs. This is because the custom chip has been designed for fast compile of the design into the system, and as well as built in all the infrastructure for the debugging. So he has native full visibility of all signals inside the emulator. And together with the hardware emulation comes a set of tools that will allow to verify the power consumption, verify the design for test infrastructure, to verify the software, and as well to verify the architectures at the C, C++ level together with a portion of the RTL. And so all these are driven by the Veloce operating system software that drives the user to the mapping of the design into the emulator and as well to debug the different runs. So this is an enterprise structure that allows multi-user. And now we have been adding to this interactive tool, we have been adding performance. Performance with the Veloce Primo and the Veloce proFPGA platform that are two prototyping systems based on commercial FPGAs. And these performance, are achieved, creating an architecture that will optimize the performance versus interactivity. We have stabilized the design with the emulation, and now we bring the design into a platform that offers sufficient performance to run the massive workloads that are needed for verifying the full set of features that will be implemented in software on the system. And we have two platforms. One is the Veloce Primo, which is like the emulator, is closer to the emulator use mode, is an enterprise prototyping system, which mimics the use mode methodology used with the emulator. And so it facilitates the migration of the design from the emulation to the prototyping system for accelerating the run of the verification of the software. And this tool, is then complemented by the Veloce proFPGA, which is more a portable desktop lab type of prototyping system, which is used for maximizing the productivity of the single engineers, creating the verification environment that is needed for a particular task. And adding these two hardware platforms, Veloce Primo, Veloce proFPGA, into this environment that we have been creating for the Veloce Strato emulation system, they will benefit from the same type of methodology, same type of tools. Obviously, there are changes on the back end because the architectures are different, but the user experience and methodology is consistent among the different systems that are used in the process. Obviously, it could be used combined each other, but could be used on individual chunks depending on the needs of the particular project teams or company. And if you zoom for a moment into the FPGA platform, I tried to explain why we have two platforms. The one is, as I said, the enterprise prototyping platform is the Veloce Primo, which is more an enterprise multi-user, the type of environment and solution that sits probably into a data center and is used remotely by the different teams and engineers that are working on a particular project. And the other side of the spectrum, we have the Veloce proFPGA, which is more a desktop type of prototyping platform available to the single engineer or to the single team. And this is something that could be customized to a particular verification requirement. And as well, it could be ported in the field for doing field testing, as well to be shared among partners and customers to offer them a pre-silicon working platform to start developing the different applications for the particular projects. And now if you look at an experience from one of our customers that has been presented at the latest user-to-user conference that has been held in Munich last spring, Intel shows where the Veloce proFPGA platform is used, and is used well before the silicon availability, and is used for running production software. So the platform, thanks to the performance that is possible to achieve with this portable prototyping solution, and we'll understand why it's possible to maximize the performance with this platform. I mean, they are capable of creating the actual operating environment around the chip that is under development, and as well as they are able to start running production software on top of this platform. And the benefits, I mean, thanks to the performance that they can achieve on the range of the 20 megahertz, for example, in this particular case, they are able to identify bugs, critical bugs on the system that were impossible to identify through the early phases of the verification process. This is now because we are running, complex and massive workloads against the hardware that is designed, and as well the creating this production environment of the chip. I mean, they can apply the same environment when the silicon is back from the foundry. So this accelerates the bring up of the silicon because they are applying a golden model against it, a golden model that's already been verified, and so they can quickly identify problems that are related to the silicon itself, and not to the bring up environment that has been fully verified with the prototyping system. And now, if you look a bit in details into the proFPGA platform, we see that is a very modular and a scalable system. I mean, the system consists of FPGA modules that could be used on different motherboards and different system configuration. It could be a single FPGA on the Uno system, or could be 2 FPGAs on the Duo system, or 4 FPGAs on the Quad system. And this is if you look at the Uno, for example, is something that stands on the hand. I mean, this is the size, a bit larger of the size of the actual FPGA device. And this FPGA module could be reused on the different platforms, on the different systems, and so allows to move, IPs and portions of the designs that have been verified with one system configuration, importing this FPGA into another system to accelerate the creation of the full system on chip that is under development. And the characteristic of this system is that is fully configurable, so there are no fixed interconnects among the different parts that constitute the system. It could be multiple FPGAs or interface boards. So, I mean, everything is accessible to the engineer, so he can create exactly the configuration that is needed for his particular need. And he has access to all the IOs of the FPGAs, so you can use particular cables or boards to interconnect the multiple FPGAs if they needed to have more than one FPGAs for mapping complex designs, or can plug particular interfaces board to the system to create interfaces to PCI Express, USB, and so forth at speed. So there is no speed bridges that will limit the overall performance of the system itself. So there is all one-on-one connections between the different FPGAs that are possible, and as well all the infrastructure has been designed, all the PCB has been designed for reaching the maximum speed, and as well we support the latest FPGAs. I mean the UltraScale Plus BU19P, but as well the Stratix 10M from Intel, and as well is possible to mix up different types of FPGAs on a particular platform. So you can have, for example, an Ultra-Scale Plus View19P together with a Zinc FPGA because you need to have the ARM core subset, or other FPGAs because you may need high-speed serial transceivers or memories and so forth. So it's possible to create an heterogeneous FPGA environment to match exactly what are the needs for creating the configuration of a particular design. And then if you need, if you have a more than one quad system, we offer racks to organize the multi-quad system in an efficient way. And this system is proven, and there are more than 200 active customers with 2,700 installations. So it's a system that comes with a certain number of optional boards and accessories. Cables are available, different memory boards, different interface board for PCI Express, SATA, MIPI, etc. And as well cages and boxes to protect the prototyping system that may be brought around for testing purposes to third parties or to the field. So the system is consistently used among the different steps of the project, from the IP development to the subsystem and to the software development running the production software workloads. And all these share exactly the same type of interface board, the same type of cables and the accessories that complement the whole environment. And if we look at now at the way how to use it from the software point of view, I mean, the system comes with a set of software tools that will allow to run, self-test, diagnostics of the particular hardware configuration that is created. And then for mapping the design, we can have a completely manual flow using the FPGA vendors tools from AMD and Intel for synthesizing, placing and routing the design and generating the bitstream and then running the design. So there could be a complete manual process. And then bringing proFPGA into the Siemens EDA strategy and offering, we have been adding, as we said at the beginning, the software for automating the process of mapping the design into the system, in particular when there are more than one FPGAs that are used for mapping the design. Automatic partitioning, automatic transformation of the ASIC netlist to make it friendly when running on the FPGAs and to avoid potential timing issues. And as well creating all the infrastructure that is needed for debugging the system itself. So the software does, as we mentioned, here we have more details, the automatic transformations and recognitions of the clock trees to ensure that gated clocks, generated clocks are working properly in a lookup table-based architecture of the FPGAs. And so we transform this clock tree in clock-enabled type of system to avoid the potential timing issues. As well, we do automatic infilling of memories using the FPGA resources that are available for the memories, but as well as we have seen before, using the larger memories available on the optional memory boards that we offer with the proFPGA system, off-the-shelf boards that are available. Obviously, the user as well can create their own custom boards and plug it into the system. And we offer backdoor read and write possibilities into those memories. And as well, for the memories, it's possible to use a soft model, where I mean all the controller the DDRs, for example, is mapped from RTL into the FPGA, and the memory matrix is based on the actual memories available on the platform itself. So for debugging, are available two approaches to the design. One is the probe-based type of debug environment, which is at speed, so it's not intrusive, it doesn't penalize the performance of the system, and the user defines a certain number of probes that will be used for analyzing the functionalities of the design that is verified with the ProFPGA platform. So the system allows a massive amount of signals that could be predefined for debug without the need of recompiling for adding new probes for the debug purposes. So is organized on debug stations, and each debug station has the possibility of handling around 10,000 signals, and you can have more than 200 debug stations into a single FPGAs. And this system is running at operations at 300 megahertz, so it doesn't impact the actual performance of the prototyping system. And the other way to approach things when you want to have a precise visibility on the different operations of the system is what is a full visibility type of debug solution. And here, obviously, the performance drop because now we are reading back the different data from the different registers and flip-flops of the system, of the design, and then we do a reconstruction of the combinatorial activities, reading and analyzing the data that has been captured from the different registers and flip-flops. But you will then have a full visibility of all signals of your design for doing a precise analysis and debug of the problem, and to accelerate the identification of the potential source of the problem. And this comes with a complete graphical user interface that drives and helps the designer to analyze the different activities of the design and tracing back the different signals up to the source of the potential source of the problem. So it's possible to visualize the entire activity of the design thanks to the different debug infrastructures and methods that are implemented and made possible by the software that comes with the ProFPGA platform. And with that, I would like to show a case study of a customer, a Keysight, that acquired a company in Germany, Micram, that is providing very high-speed analog digital converters. And they are using the ProFPGA for creating a self-contained environment to validate their IC, DC, IPs, and chips together with the logic that will be implemented by the end users. So they have created a custom type of interface to the ProFPGA system. It could be a Uno and Duo, and they can offer this platform obviously to the internal teams for doing a system verification of the environment with a particular logic for a particular application, but as well as they can share that with their customers to enable them to validate their architecture together with the IPs that they are providing them. And here is a case when they are running at speed. I mean, this is a very high performance, fully programmable real-time prototyping system that is offered by Keysight. And I encourage you to look at their website for the USPA platform, and you can see more details about the solution that they are offering. So with that, I would like to conclude this overview of the proFPGA platform used for accelerating the verification of the software for your design. And I would like to remind you that this is the focus of the platforms is on the performance. So to offer the highest possible performance to run massive workloads and the complete set of software applications that could be used in conjunction with the hardware that is under development. It's a system that is easy to set up. It doesn't require the particular logistic for its use. I mean, it's a desktop lab type of a platform, and as well it comes with the possibility of automating all the tasks for mapping the design into the FPGA platform, so to accelerate as well the bring up of design on the platform itself. And it's very modular, scalable, and you can create exactly the environment that you need using the proFPGA native and available solutions that come with the platform. But as well as we have seen on the Keysight case, you can create your own verification environment, create your custom interfaces and custom boards to reproduce exactly what you need for your particular application. And if your needs scale up on time, needing more capacity or additional boards, and this is possible because the system scales up with consistency from one type of platform to another one. So with that, I would like to thank you for attending this session, and now is open to the Q&A. Thank you very much.